Okay, let's take a look at problem number 1. It says, what is the measure of angle 2 in this rectangle below? So, right off the bat, I know I have a rectangle. So, that's a parallelogram. Opposite sides are parallel and congruent. Okay, but more importantly, I have equiangular. Okay, it's also important to notice. And I also know in a rectangle, my diagonals are congruent, right? So AC is congruent to BD. Well, because this rectangle is a parallelogram, not only does it have the property of diagonals being congruent from being a rectangle, but it also has the properties that the diagonals bisect each other from being a parallelogram. So because these diagonals were equal to begin with, when the diagonals bisect each other, the pieces will be congruent too. And what's really nice is we now have an isosceles triangle down here, right? That's kind of what I'll eventually be. Ooh, that's not very good. Let's make it a little bit better. That's what I'll eventually be coming to. This is A, right? A, D, and E. Okay? Well, let's bring our attention back to the rectangle. We have this 25-degree angle up here. And I'm going to extend my parallel lines, extend those parallel lines. And I guess I'll do this in blue. And we're going to extend this diagonal so that it's transversal. That's another property of rectangle. The diagonals are transversals. So those green parallel lines, we have a Z here, right? There's our alternate interior angles. So here's the Z. Okay. So this 25-degree angle comes down here, 25 degrees. When our triangle, angle D, is 25 degrees. And because this is an isosceles triangle, angle A must also be 25 degrees. And we know in total, in a triangle, there's 180 degrees. And since between angle A and angle D, there's 50, we take our 180, subtract that 50, and we're going to find angle E. There's 130 degrees left for angle E in that triangle. And angle E, this 130, is at angle 2. So we can conclude the measure of angle 2 is 130 degrees. Great. Thank you.